September 19th, 2021, 2:13 p.m. A satellite 500 kilometers above Earth detected something that would change everything for 50,000 people living on an island in the Atlantic. What the satellite saw became one of the most violent volcanic eruptions Europe had seen in 50 years. But here's what almost nobody knows. The satellite saw it coming. Weeks before it happened. La Palma, Canary Islands. 85,000 people living on a volcanic island in the middle of the Atlantic. For decades, scientists knew this volcano would erupt again. They just didn't know when. Until 2021, when we could finally see the warning signs from space. Before we dive into this story, make sure you're subscribed. I cover technologies that are quietly changing our world, and you don't want to miss what's coming. Today, I'll show you 3 things. The invisible signals satellites detected weeks before the eruption, how this early warning saved lives, and why this technology is revolutionizing disaster response worldwide. Let's rewind to early September 2021, 3 weeks before the eruption. September 1st through 5th, the European Space Agency's Sentinel-1 satellite makes its routine pass over La Palma. Its synthetic aperture radar scans the island, penetrating clouds and darkness, measuring the ground with millimeter precision, and it detects something invisible to every human eye on the island below. The ground is moving, rising, swelling upward by several centimeters. The volcano is literally inflating. Deep beneath the surface, a massive chamber of molten rock is filling with magma, pushing the Earth upward like a balloon being slowly inflated. In SAR technology, interferometric synthetic aperture radar compares this image to ones taken days earlier, creating a deformation map. The colors show displacement, and the pattern is unmistakable. September 8th through 12th, 2 weeks before eruption. Now thermal sensors join the observation. Sentinel-2's infrared cameras detect something else invisible from the ground. Temperature anomalies. Specific volcanic vents are getting warmer. Not dramatically, these aren't visible plumes of steam yet. But the thermal signature is clear. Heat is rising from below. The mountain is warming from the inside out. Something is moving underground, and it's getting closer to the surface. September 13th through 18th. 1 week before eruption. The deformation is accelerating. What was centimeters is now 10 centimeters of uplift concentrated in the volcanic cone. Multiple satellites are now monitoring continuously. American, European, commercial systems all focused on this small island. Scientists at monitoring stations watch the data come in every few hours. The pattern matches every pre-eruption signature they've studied. Ground swelling, thermal increase, seismic activity rising, every indicator pointing in the same direction. By September 18th, 24 hours before the eruption, scientists knew with absolute certainty this volcano was going to erupt, not someday, not eventually, soon, very soon. The only question left was exactly when. And more importantly, what would they do with this knowledge? So how does a satellite see what human eyes cannot? Let me break down the 3 technologies that made this detection possible. First, insar interferometric synthetic aperture radar. This isn't a camera taking pictures. It's a radar system that bounces microwave signals off the ground and measures how long they take to return. When the satellite passes over the same location days later, it compares the 2 radar images. Any change in distance, even by millimeters, shows up as a color shift in the interference pattern. It's like having a ruler in space measuring the height of every point on Earth with incredible precision. And because it's radar, not optical, it works through clouds, through darkness, 24 hours a day. Second, thermal infrared imaging. These sensors measure heat signatures completely invisible to normal cameras. They detect the infrared radiation emitted by warm objects, including magma moving beneath volcanic vents. While everything might look normal in visible light, thermal cameras reveal the truth. They can spot a temperature increase of just a few degrees across an entire mountainside, identifying exactly where heat is concentrating and rising. Third, artificial intelligence. The satellites generate massive amounts of data terabytes every day. Humans can't possibly analyze it all. So machine learning algorithms do the heavy lifting. They compare current images against decades of historical baselines. They've been trained on every volcanic eruption ever recorded from space. When they spot anomalies that match pre-eruption patterns, they generate automatic alerts. The satellite doesn't just watch. It thinks, it predicts. September 19th, 2021, 3:12 p.m. local time. Cumbre Vieja erupts. The explosion is violent. Lava fountains shoot 500 meters into the air higher than the Empire State Building. Multiple fissures tear open across the volcanic ridge, each one spewing molten rock. The lava doesn't just ooze, it flows at 700 meters per hour. A wall of 1,200-degree destruction moving toward populated areas below. And it doesn't stop. This isn't a brief eruption. Day after day, week after week, the volcano continues 85 days. Nearly 3 months of continuous eruption, the longest in La Palma's recorded history. Rivers of lava carve through neighborhoods, farms, forests. Everything in their path is consumed. 3,000 buildings destroyed. Homes where families lived for generations, buried under meters of solidified rock. Agricultural land that fed communities for centuries turned into barren lava fields. 7,000 people displaced from everything they knew. The economic damage reaches $900 million. Insurance companies scramble. Entire communities are erased from the map. By any measure, by any definition, this is a catastrophe. The destructive power of the Earth made visible. One of the most violent volcanic eruptions Europe had witnessed in half a century. But here's the number that matters most. The number that changes everything about this story. The number of deaths caused directly by this eruption. 0 deaths. Not one person killed by the eruption itself. Let that sink in for a moment. 3,000 buildings destroyed, 7,000 people displaced, 900 million in damages, but everyone survived. How? Because of what those satellites saw weeks earlier. September 18th, one day before the eruption began, emergency management officials issued preemptive evacuation orders. Not reactive orders after lava started flowing, preemptive based. Entirely on satellite data showing ground deformation and thermal anomalies. 5,500 people were evacuated before the first fissure opened. They packed their belongings calmly, said goodbye to their homes with time to grieve, moved to safety while roads were clear and panic was absent. The satellite deformation maps didn't just say evacuate the island, they identified specific, high-risk zones with precision. Which neighborhoods sat directly above the inflating magma chamber? Which areas would likely see lava flows based on topography and historical patterns? Targeted evacuations, efficient, effective. Then, as the eruption began, the satellites shifted roles from prediction to real-time monitoring. Every 6 to 12 hours, new images captured the lava's advance. Thermal sensors tracked flow, temperature, and speed. Radar measured exactly how much lava was being produced. AI algorithms predicted where flows would go next, updating projections as new fissures opened. Another 1,500 people were evacuated in the first 24 hours of eruption, not in panic, not fleeing from lava they could see approaching, but calmly, systematically, moving ahead of flows that satellites predicted would reach them in hours or days. People moved in front of the destruction, never behind it. Compare this to history. 1902, Mount Pelée in Martinique erupts with no warning system. 29,000 people dead in minutes. 1985, Nevado del Ruiz in Colombia. Warnings existed but were ignored or communicated poorly. 25,000 dead. 2021, La Palma, full satellite monitoring. Clear communication, decisive action. 0 deaths. The difference? eyes in the sky that could see what was coming, and people on the ground who trusted what those eyes were showing them. You probably never heard their names. Satellite operators monitoring data feeds 24/7. Scientists analyzing deformation patterns. Emergency officials trusting information they couldn't see with their own eyes. No dramatic rescues, just preparation. And it worked. La Palma wasn't a one-time miracle. This is happening worldwide, right now. Himalayan Glacial Lake, 2023. A satellite detected a crack forming in a natural ice dam holding back millions of cubic meters of water in Bhutan. The lake sat high in the mountains above a populated valley. If that dam failed, the resulting flood would be catastrophic. 3 weeks of warning from satellite monitoring allowed authorities to evacuate 12 villages downstream. Engineers executed a controlled release, gradually lowering the water level before the dam could fail catastrophically. When the crack finally widened, the reduced water volume prevented disaster. 0 casualties. Brazil, ongoing since 2019. After the Brumadinho Dam collapse killed 270 people, Brazil implemented mandatory satellite monitoring of all high-risk tailings dams. 50-plus dams now under continuous INSAR surveillance. The system has already detected structural deformation in 3 dams before any visible damage appeared on the ground. Preventive repairs were initiated immediately. Potential catastrophes identified and prevented before they could claim lives. California, 2023. Thermal satellites detected heat stress in vegetation across multiple regions, dried out brush reaching critical temperature thresholds. Not fires yet, pre-fire conditions. 48 to 72 hours before ignition typically occurs. This early warning allowed firefighting resources to pre-position in high-risk areas. For incidents that would have become major wildfires were caught in their first hours, contained before they could spread. Homes saved, lives protected. All because satellites saw the danger before flames appeared. Different disasters, different continents, same pattern. Satellites detecting the invisible warning signs. Officials acting on that intelligence. Lives saved that would have been lost just a decade ago. Right now, above your head, a network is watching, protecting you without you ever knowing it's there. The Copernicus program, run by the European Union, a fleet of Sentinel satellites, each one specialized for different types of monitoring. Sentinel-1 for ground deformation, Sentinel-2 for optical and thermal imaging, Sentinel-3 for ocean and atmospheric monitoring. All of their data freely available to scientists and emergency responders worldwide. NASA's Landsat program. Over 50 years of continuous Earth observation. The longest-running satellite program in history. Every image archived, creating a historical record that allows us to compare current conditions against decades of baseline data, essential for detecting anomalies. Planet Labs. 200-plus small satellites providing daily coverage of the entire Earth, commercial, but collaborating with disaster response agencies. When catastrophe strikes, they redirect their constellation to provide high-frequency monitoring of affected areas. National systems from the United States, China, India, Japan, and dozens of other countries, each adding their capabilities to the global network. Competition on Earth, but cooperation in space when lives are at stake. Every point on our planet is now imaged at least once per day. High-risk areas, active volcanoes, unstable slopes, aging infrastructure. Wildfire zones are monitored multiple times per day. The data flows continuously to emergency management centers, research institutions, and disaster response coordinators. The entire planet under observation. Not for surveillance, for protection. Your invisible shield, operating silently 500 kilometers above you every single day. You might be thinking, I don't live near a volcano. Why does this matter to me? Here's why. 40% of the global population lives in disaster-prone areas. Flood zones, hurricane corridors, earthquake regions, wildfire territories. and satellites monitor all of them. That emergency alert you received on your phone last year, there's a good chance it came from satellite data. Hurricane warnings with 5 days of advance notice satellites track the storm from formation to landfall. Flood alerts telling you to evacuate before the river crest satellites measured rainfall upstream and predicted flow rates. Wildfire evacuation orders that seemed to come surprisingly early satellites detected heat buildup in vegetation before ignition. You've already been protected by this technology. You just didn't know it. But the system only works when we trust it and act on it. Consider what happens when we don't. Turkey and Syria. February 2023, a massive earthquake strikes. Over 50,000 deaths. Limited early warning capability for earthquakes still exists. But satellite monitoring of building integrity could have identified the most vulnerable structures before they collapsed. Libya. September 2023, catastrophic floods kill 20,000 people when aging dams fail. Satellite monitoring existed, but response infrastructure was inadequate. The technology is there. The satellites are watching. But they can only save lives if we listen. Sign up for emergency alerts in your area. Know your evacuation routes. And when satellites detect danger and authorities issue warnings, take them seriously. Your life might depend on someone watching from space. Let's return to La Palma. Life is rebuilding. Those 50,000 people are alive because someone 500 kilometers above was watching. They had time to prepare, to evacuate, to save what mattered. We can't stop disasters, but we can see them coming. We can save lives. It's happening now. Most don't know it. Share this if it opened your eyes. Subscribe for more invisible tech. Comment, what hidden technology should I cover next?